All right, so I'm going to go to my screen and share it. All right, let me get situated here. All right, y'all, so 6.1. deals with radical functions. And what we mean by radical function is you'll have something like f of x equals a square root of whatever's under that radical, okay? So we're going to start out looking at the domain of a radical function. And if you remember, this was the second thing I was worried about on a domain. The first thing was the fractions, because the bottom of the fraction couldn't equal 0. On a radical, what's underneath the radical, so right here, this a that's underneath the radical, we know that that has to be greater than or equal to 0. Because if you put a negative number under that radical, you're going to get what we call imaginary numbers. And imaginary numbers are not real. So on the domain of a radical function, we set the radicand, and y'all, the radicand is just what's under the radical. So we set the radicand greater than or equal to 0. Okay, then we solve that, and then we're going to write our answers in what we call set builder notation. Let's see, there's only one or two in the homework where you had to find the domain. So my first one, we're going to find the domain. So for number 1, I'm going to have f of x equals the square root 4x plus 3. And all this is up under the radical, so I'm worried about this whole expression. So what we're being told to do is take that 4x plus 3 and set it greater than or equal to 0. All right, so let's solve that for the x. So we'll subtract 3 from both sides. And I get 4x is greater than or equal to a negative 3. And then we'll divide both sides by 4. So that x is greater than or equal to a negative 3/4. Okay, now remember, at this step, when you're dividing, if you divide by a negative number, you got to flip the inequality around. But since we didn't divide, we're good. So for the answer, MATLAB will put x and the line. And all we do is come in and put our answer, x is greater than or equal to a negative 3/4. Okay, so I'm going to do another one similar to that. I'm going to do f of x equals a square root of 5 minus x. So I wanted to do one of both styles. I think MATLAB only does one of these problems, but I wanted y'all to see one where the x is being subtracted. So once again, we're going to set this greater than or equal to 0. And then I'm going to solve this for the x. Y'all, two ways to solve this. One way, you could have come in and added an x to both sides. But when you put the answer in MATLAB, it likes that X first and then the number. So just remember to flip it around if you did that. So what I'm going to do is subtract 5 from both sides. So that'll give me negative X is greater than or equal to a negative 5. And then I'm now going to divide by that negative 1. Since I'm dividing by the negative 1, the greater than or equal will now be a less than or equal. And then a negative divided by negative makes that a positive X. And then a negative divided by negative makes that a positive 5. So for this one, we would come in X such that X is less than or equal to a positive 5. Okay, so either way you solved it, you'd have got the same answer. All right, let me let y'all write that a second. Then we'll look at graphing. All right, y'all, so we'll go to graphing. So for radicals, one of our basic graphs the other day, we had one that was f of x equals a square root of a. That basic graph, remember, so let me try to draw a graph here. And then we'll do a few numbers just to see. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I'll put these on the calculator also. So for the basic graph, if we had a basic table here, and I'm just going to use a few numbers. I'll use a 0, a 1, a 2, and I might even go to a 3. Oh, let's put a 4 here. Because some of these I'm not going to be able to do and graph them, and I wanted y'all to see what was up. So if you put a 0 into the radical, watch this, second x squared to get the radical. You put a 0 in, you're going to get a 0. Square root of 1, you take the square root of a 1, you're going to get a 1. Now, had I been doing this by hand and drawing this, I probably wouldn't have picked the x of 2, because watch what happens when you try to take the square root of a 2. You get a 1.414, which is sort of like a decimal, and I'm not wanting to plot decimals. 3 would do the same thing. Second square root of a 3 gives me 1.732. These are numbers I don't want to actually graph, but if you'll pick numbers like 0, 1, 4, because 4 has a square root of 2. Oh, the next number I'd have probably picked on my x's would have been a 9, because 9 has a square root of 3. But y'all watch the graph. It starts at 0, 0 here in the origin. When x is 1, y is 1. Then I'm going to go down here. When x is 4, y is 2. So come over here to 4, go up to 2. Now these other numbers, 2, there would have been a 1.4 in here and a 1.7 at the 3. But I just wanted y'all to see the basic graph is sort of going to come up and go to the right. Okay, so what we're going to do is look at what's happening on these graphs. So let's graph f of x equals 3 times the square root of x. So let me tell you what's happening with these numbers in front of the radical. So if we have something like b times square root of a if the b is greater than or equal to 0, oh, let's put a 1 there. I think that's a 1. If the b is greater than or equal to 1, then the graph stretches. If that b is less than 1, then the graph shrinks. So what I'm saying is, stretching this graph will want to go uphill a lot more, and if it shrinks, it's going to try to get closer to the x-axis. Now, I don't think any of the examples they put a fraction here. It's always a nice whole number, which means we're just going to stretch them. So the numbers I would pick on this would be a 0, a 1, and a 4. I'm picking the numbers that have nice square roots here, so I can avoid plotting those fractions, okay? And we'll do that on the calculator in a second. So y'all, if we put a 0 in here, square root of 0 is 0, and 0 times 3 is 0. So work the radical first and then multiply. If I put a 1 in for that x, square root of 1 is 1, and 1 times 3 will give me 3. And then if I put a 4 into that radical, square root of 4 is 2, and 2 times 3 would be 6. So notice what it did to all my y values. Before I had a 0, which is the same. At 1, we had a 1, but now this one says at 1, we got a y value of 3, so it's sort of going to stretch it up there. So let's see, I'll go at 1, 2, 3, 4, 5, 6. Then -5 that way and -5 this way. All right, so here we go. We had 0, 0, which is in the same spot. So see, it's not shifting the graph up or down. It's stretching it from the same starting point. And then we got 1, 3. And then I had 4, 6. So if you notice, this is now a lot. It sort of stretched it on up there for us. All right, so on the calculator, if you wanted to do them by calculator, to get that radical, first we want the 3. To get the radical, I hit the second x squared button, and then underneath I just put my x. And if you wanted to see the table, you would do second graph. See all them errors? That's because we tried to take the square root of a negative number if x was negative. Okay? Those are giving you imaginary answers. So there's my 0, 0, my 1, 3. I didn't want the decimals. I didn't want them decimals. So I went to 4, and that gave us 6. And y'all, let's look at the picture. Should look pretty much like ours. And there you go. Now remember, theirs is going out to 10 on the standard window on your calculator, okay? Alrighty, so I'm going to try this one. We're going to graph f of x equals a -2 square root of x. So the 2 is still going to stretch it out a little bit because it's not a fraction. But remember, that negative is also going to do something. That negative is going to take my graph and flip it over the x-axis. So y'all, I'm going to use my 0, 1, and 4 again. So let's see what happens. We put a 0 in for the x. Square root of 0 is 0. 0 times -2 is still 0. So it's still going to start at that origin for us. I put a 1 in. Square root of 1 is 1. 1 times negative 2 is negative 2. So now notice it's making my y values negative because of that negative. All right, put a 4 in. Square root of 4 is 2. 2 times negative 2 would be a negative 4. All right, so let's draw that. So I can go out about 5 on this one. So my y and my x. All right, let me pull my camera down a little bit so I can see that bottom. All right, so here we go. At 0, 0, we're right in the center. You know, what's nice on this, you don't have to graph them into MATLAB. It's going to have 4 pictures, and you just pick the picture that matches your graph, okay? All right, then I had 1, negative 2, so here's 1, negative 2. So see, it's bringing it down instead of up. And then we had 4, negative 4, which put me down here. So the same type curve, it's just now it's going downhill instead of uphill. So let's see what our calculator does. What do we have? Negative 2, second x squared to get the radical, and then my x. So I'm going to go straight to the graph. And y'all, there you go. All right, so let me give y'all a second, then I'm going to do some tricky ones here. All right, y'all, so this next example, I'm going to graph f of x equals the square root x minus 9. And I will say, I'm definitely going to be picky on this one when I do my x's and my y's. Now remember, y'all can just graph this one on the calculator and then pick out one of the 4 pictures. So I know the smallest number I can take square root of is 0. So let me find the x that makes this equal 0, and that would be a 9. My smallest x has to be a 9, because if you put an 8 in there, 8 minus 9 is negative 1, which will make that imaginary. If I use a 0, 0 minus 9 is negative 9, which is imaginary. So we need numbers that'll keep this positive under that radical, okay? So the smallest number I can use is a 9. I'm going to use a 10 because I know 10 minus 9 is 1. And I can still take the square root of a 1. Now the next number I can take the square root of after 1 would be 4. So what would make this equal 4? And that would be a 13. 13 minus 9 is 4, and that'll give me a good number. If I did 11 and 12, remember that would give me numbers that give you decimals when you take the square roots, okay? So watch this. Put a 9 in. 9 minus 9 is 0. Square root of 0 is 0. Put a 10 in there. 10 minus 9 is 1. Square root of 1 is 1. And then finally, I'll put my 13 in there. 13 minus 9 is 4. Square root of 4 is 2. So it looks like before, to get a y value of 0, I was at x equals 0, right in the origin. But now, I'm all the way over here at 9 to get my 0. And we knew that because when this is a negative 9, inside parentheses, because you got to treat radicals like they're in parentheses, We knew that when you attack the X inside parentheses, if it's negative, it moves you right. And if it was positive, it would move me left. All right, y'all, try to draw this one. I'm gonna have to go out a little further though. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, then I'm gonna go up. 1, 2, 3, 4, 5. And let's see, that'd be my Y and my X's. I'm not going to number the other stuff because everything I got is positive up here. So here we go at 9, over here at 9, we got 0. Ooh, I need to go a little longer, don't I? All right, that'll be 11, 12, 13. All right, so what I'll do at 10, I was at 1. And then at 13, 11, 12, 13, I was at 2. So it's the same graph as the basic graph, but that -9 moved it over 9 units to the right. Now remember, if you do this one on your calculator, you got to put the radical first. So second x squared to get the radical, and then do x minus 9 under that radical. If you got the old calculator, when you do the radical, it does like a radical and a parenthesis. You got to put the x minus 9 in parentheses and close them. New calculators, it puts the radical over everything like mine. So let's graph. And we'll notice it starts right over here at the 9. So if we wanted to see more, we would have to arrow right. Let me think. I'm trying to get my x's to go right. Oh, now I'm going to have to trace it, I guess. All right, so let me get to the 9. Now that I'm tracing it, it'll keep going to get the graph like we got. Okay? So notice how it just does like a little slight elevation as it goes to the right. All right, y'all. So final one I'll do, we will graph f of x equals square root 2x minus 7. All right, so I'm just going to go to my calculator and knock this one out. So I got my square root, second x squared. Underneath, I'm going to put 2x minus 7. So let's look at the table first. So I'm going to hit second graph to look at my table. So notice anything less than 4 is going to give you imaginary numbers. So look, good numbers to pick would have been 4. Because 4 times 2 is 8. 8 minus 7 would have gave me 1. 3, because that would have been, let's see, what's next? 8, because that'd be 16 minus 7, which would be 9. Square root of 9 is 3. So you notice you want to be sort of picky on your numbers. All right, we want to see the graph. Well, let me go back to my normal page. Zoom standard. All right, that'll get me back. And notice all it did is it just shifted it to the right a little bit on us, okay? So 1, 2, 3, 4, 5. All right, so second table. So I know at 4, I was at 1. At 8, I was at 3. So there's 6, 7, 8. We went up to 3. And if you notice, all it's done was took my little graph and moved it to the right. Y'all, what I was telling you about, if you notice, look at their answers. On those, they give you 4. This one moved left. This one looks like it moved right. This one moved left and switched. And y'all, somehow that's a straight line, which has no possibilities, okay? So you'll just go in and pick pictures on each of these. All right, let's see. So next, we're getting into 6.8. And it covers a few things. It covers increasing, decreasing, and we're going to look at piecewise functions. So we're going to start with piecewise functions, sort of go through the definition of them. Then we'll get into the increasing and decreasing. So a piecewise function. So y'all, the best way to show y'all what a piecewise function is I'm going to work an example. And so for this example, I'm going to have P of T equals, so P for me represents pay, T represents time in hours. So y'all watch what I do. P of T will equal 40 times T if T is less than or equal to 40. Okay. Now, P of T will equal 40 times T plus, oh, what am I wanting here? What's that'd be 60 times T minus 40 if T is greater than 40. So what I'm doing here, P represents your pay, T is time in hours. So my person makes $40 an hour. So to figure out their paycheck, if they work 40 hours or less, you would take their pay times their hours and get the paycheck. Oh, and right here, I probably should have made this a, in my formula, I probably should have made this 1600. Because we would have known that 40 hours, 40 times 40 would have gave them 16 hours. So what I'm doing, figuring out right here, is their time and a half pay, right? Time and a half at 40 would be 60. And then you take the total hours minus the 40 that gave you your regular pay. So if I work 60 hours, I would do 60 minus 40 would give me 20 hours at overtime times my time and a half pay. Okay, so y'all should probably do this kind of stuff if you ever work overtime at a job. You get time and a half. Anything over 40, up to 40, you would get your regular pay times your hours. So hopefully that makes sense on these piecewise functions. So what a piecewise function would do, if I work 35 hours, which equation would I use? So these are what's giving us our domains, the T less than or equal to 40 or the T greater than 40. You take your hours, 35, and you find which domain they fit in. Well, I know 35 is less than or equal to 40, which means I would use the 40 times T, okay? If I worked 42 hours, which equation would I use? All right, so 42 hours is greater than 40. So since 42 hours is greater than 40, I would use this equation, which is 1600 plus my time and a half pay times 42 minus my 40 would give me my actual pay. So remember, this if t less than or equal to 40 or t greater than 40 ain't part of the equation. They just give you the range that your numbers have to be within, okay? So let me show you one like they use. All right, so they say the piecewise function f is defined as f of x is going to equal, so this one's going to have three equations. It's going to equal 3x for x less than a -2. It's going to equal x minus 4 for -2 less than or equal to x less than 5. And y'all, it's going to equal x squared for any x that's greater than or equal to a 5. So, which expression would be used to find, where am I at? F of 8. All right, so which expression would be used to find f of 8? So what I got to do is figure out if 8 is less than -2, if 8 is in between a -2 but less than 5, or is 8 greater than or equal to 5? So we know that 8 is greater than or equal to 5, so the expression we would use, or the equation, would be x squared. Okay, so they'll give you a number, you'll find your domain that it sits in, and then use that equation. Now, at the moment, they don't want us to find f of 8, they just wanted me to know which equation. I think at the end of this homework, they start asking us for the actual values on them, okay? All right, let me let y'all catch that up. All righty, so let's look at increasing and decreasing. Whoa, let me get my. All right, so an increasing interval. All right, to be an increasing interval, the graph rises from left to right. Which means to be increasing, they got to have positive slopes. So remember, we're going left to right. You cannot read it right to left. Now let me pull over more. So graph rises from left to right and decreasing interval. The graph is going to fall from left to right. Which will mean go downhill. So things you got to think of. Increasing has positive slopes left to right, goes uphill. Decreasing has a negative slope, goes downhill. The thing on these intervals are only denoted by using the domain values. And remember, the domain values are your x's. We just want to know intervals where it rises and falls. We don't care how much it rose or how much it falls. We just want to know those intervals where it is going uphill and downhill. And then the last interval on these is constant. Constant means it stays the same. So a constant interval is a horizontal line from left to right. Okay, increasing uphill, decreasing downhill. Constant would be straight across. And remember, it still goes left to right, okay? So I think I'm going to see how good y'all can see this. Can y'all see my graphs pretty good? Right here. So notice what they're going to ask you. They're going to ask you first, the function is increasing on what interval? So increasing is this part where it's going uphill. So what I'm worried about is that x value. And look at this. This arrow keeps going on and on and on, which means my x's are going to keep going and going to the right. So my interval will start at 1, 2, looks like starts at 3. So for increasing, and remember, we're going to use curves on these. It started at 3, and it's going uphill as I go out my x's towards infinity. So there's no stopping point. It keeps going and going. So that would go from 3 to infinity on the x's, increasing. So notice what they got. That would be this C right here. So I don't know where they got the 2 from. Oh, I see where they got the 2 from, because people would look at the y value at 2. Right? So they're using y values to get that 2, and then heading towards infinity on it. So y'all, we are only focusing on this x-axis, okay? All right, then it says the function is constant on what interval? Well, it's constant starting at this x value until it hits the x value where I started increasing. So we want to see what this x value is to that x value. So let's see, we got -1, -2, -3. So this is our constant. Started at -3, and then it's constant until I hit the x value of a +3. So we want -3, 3, which would be C again. All right, so we don't want brackets because these points can't be both constant and increasing, okay? And then I had no idea where they got the 2, 6, unless they're thinking you're going to carry the line up here or something. All right, so what we got next? Decreasing. Decreasing going left to right would be this line. So it's coming in from the left, way out here. So that means this one is starting way out here at negative infinity. And then my graph is going downhill until I hit this point right here. And on the x's, that point was what? -3. And then a curve. So we would want negative infinity to -3. So every one of my answers was a C on that one, okay? But notice your overall graph has to go from negative infinity to that -3, then from -3 to 3, and then from 3 to infinity. All right, then I got another little interesting one here. And it looks like we want to know where is increasing and decreasing and constant again. So they're starting with decreasing on this one. Well, that's constant, that's uphill. Decreasing is this third little line here. And then that last one would be increasing again. So what I need to know is what this x value is right here. So that looks like 1, 2, 3. So it starts at 3. And then it's decreasing until it hits this x value, which is what? 4, 5, 6, 7. So at the x value of 7, it starts, oh, my bad, y'all, I didn't see this one up here. Increasing. So we'll go back and get in. But that was the only little section decreasing, and it did from 3 to 7. So I guess I need to go back and do this one on increasing. Notice it's got 2 parts increasing, so that's where they're getting the and at. And back here would have been like a union, okay? So let's see. It starts increasing right here, so that's 1, 2, 3, 4, -6. It starts increasing, then it hits this at 2, so we know we're going from -6 to 2. And then it's increasing right here. Let's see, that's 1, 2, 3, 4, 5, 6, 7. So from 7, it's increasing until it hits 8. So it looks like that one just went 1 unit over and then stopped. So we need a -6, 2 and a 7, 8, which would have been B on that one. All right, then where is it constant? Well, it's constant on the straight line. So we want to see what that x value is and that x value. So it looks like this is 1, 2, 3, 4, 5, 6, -8. And then it's constant until I get to -6. Okay, so constant straight across, increasing uphill, decreasing downhill. All right, y'all, so let me find some more of these. All right, so we're going to play 6. Now notice this line goes all the way towards positive infinity, and it's coming in from negative infinity over here. So the first thing they want to know, list the intervals on which it's increasing. Well, y'all, this little hump here is increasing, and then this little piece right in here is increasing. So I'm going to start with this left hump. It's coming in, because remember that arrow goes forever, so it's coming in from negative infinity. So this is what, increasing? And then it increases till it hits this hump. But remember, I need that x value there, right? So that x value there would be -7. And then let's see, this tells us use a comma to separate our answers. So I guess I'll use a comma. And we need to see where this one's increasing. So go to the y on that. So that looks like it starts increasing at -2 on the x's. And it's increasing to this point, which looks like -1. So that's a very small interval there, but from -2 to -1, it was increasing, and then it started doing its constant. So let's see, we got increasing. Now let's the intervals on which it's decreasing. So that's going to be the downhill left to right. And the only one going downhill left to right is this little section of graph. So decreasing would start at that -7. And it's decreasing until I hit this point, which on the x is at -5. So you got to use the y's to tell me if I'm increasing or decreasing, but you only use the x's on those intervals. Now, constant on that one had 2 intervals. You had this interval and then that interval. So this interval looks like it's starting on x at -5. And then it comes over till I hit this point, which was -2. And then comma for this one. This one starts constant at -1. And it keeps going on and on forever, so it heads off towards positive infinity. All right, so I like this next one because it's going to start bringing out the what we call relative mins and relative maxes. All right, y'all, so I've done 50 minutes, so take about 10 minutes, and then I'll come back and finish out this rest. So I'm going to stop sharing and then pause my video. And then we'll go back to our screen. That's what I'm trying to get the bottom problem put on here now. All righty, so this one starts asking us about relative maximums and relative minimums. All they're talking about is little peaks and valleys, okay? So a relative max oh, that's a relative. Oh, my pen ain't doing too good. So a relative max is a peak in the graph. And a relative min is a valley in the graph. Okay, so this one are giving me a function, -x² plus 9x minus 14. They gave me the graph of it, and they want to know, does it have a relative maximum or minimum? So since we got a peak right here, we would have a relative maximum. And notice what they say here. The relative maximum occurs at x equals, so y'all, they're giving me the point here. It looks like my x value is 4.5. And then the maximum value is the y value, which is 6.25. Okay, so remember, min or max values are the y values, and they occur at those x values, okay? Almost like finding the vertex on that one, okay? So then they say, on what interval is this function increasing? So remember, increasing is going uphill. So my graph is coming uphill now. Remember, this arrow means it goes on forever. So as you come in from the left, it's increasing until we hit this x value. And they're giving me that x value. That is what, 4.5? So it's increasing from negative infinity up to the 4.5. So let's see what will we have. That'd be the B on that one. And then decreasing is this part going downhill. It's going to start at that 4.5. And remember, the graph goes on forever as you're going out these x's, and the x's are headed towards positive infinity. And that would have been 4.5 to infinity, would have been B on that one. Okay, so we're just trying to get you familiar with increasing, decreasing, and constant, and then what we call the relative mins and the relative maxes. All right, y'all, so I'm going to turn the page and go to the next one.
36.
All right, let me see. They're giving me the points here is what, -6, -1. And then this point is 2, -33. So I got a maximum at this point and a minimum at this point. So here we go. The relative maximum is, so the maximum value is the y value, which is -1. And that happened at the x value of -6. And then you do the same thing for this minimum. The minimum is the y value of a -33. And that happened at the x value of 2. Okay? So the y values are the min and max values. X values are where they happen. It's increasing twice on this one. You're coming up here, and then from this point on. So we're increasing in 2 spots. The first one is coming in from -infinity. Increase until I hit that x value of a -6. Then it's also increasing at this x value of 2 as you head towards positive infinity. So we need a -infinity, -6, and then a 2 to infinity, which would be B. And then what's the last one? Where is it decreasing? So it's only decreasing on this one little section here. So that started at an x value of -6. And it ends right here at the x value of 2. So we want a -6 to 2 on that one, which would have been D. So y'all, on the intervals, you gotta focus only on those x's, okay? All right, that was sort of the same, so I'm gonna skip it. And I'm gonna go back to these last 2 problems and work them on my actual paper, okay? Alrighty, so this is going to end up with piecewise functions, and we're going to be evaluating piecewise functions. So here's what you do. You first find the interval that your x value is part of. So if my x was 5, I'm going to go find the interval where that 5 fits in there. Second, you're going to choose the equation that matches the interval you chose. So find the x value where it fits, take that equation, and then the last thing, plug your x value into the equation that you chose. Okay, so they're going to say find me f of 2, f of 3, or whatever. You're going to find those domains where that fits, get that equation, plug your x into it, and then see what you get. And y'all, I think there is like 2 examples doing that. So this one says for the piecewise function.
Can you go back to the last page? I need to write the third part
Right there.
down. Okay, I got it. Thank you.
Okay, no problem. Y'all, so let me pull up a little bit. So for the piecewise function, we're going to find the values of g of -9, g of 1, and g of 3. So our function they're giving us for the piecewise function will be g of x equals x plus 3 for any x that is less than or equal to 1. Then it's going to equal 9 minus x for any x that is greater than 1. So there's 3 things we're finding on this. We're going to find g of -9, g of 1, and g of 3. So let's start with our g of -9. First of all, we got to figure out, is -9 less than or equal to 1? Or is -9 greater than 1? And y'all, -9 is less than or equal to 1, so I'm going to use this equation. So I picked that x plus 3 equation. But remember, it told us to take our number and put it in for that x. So this will be -9 plus 3. And then -9 plus 3 gives me a -6. So g of -9 will be a -6. Then we're going to find g of 1. Well, g of 1, we got to find out, is 1 less than or equal to 1? Or is 1 greater than 1? So 1 is definitely equal to 1, so we're going to use that equation again, which is x plus 3. In place of the x, we put our 1, so we get 1 plus 3, which will equal 4. And then finally was what? G of 3. So g of 3, we got to find out, is 3 less than or equal to 1, or is 3 greater than 1? So this time 3 is greater than 1, so I'm going to use this equation, 9 minus x. In place of the x, we put our 3, So we got 9 minus 3, which will give us positive 6. So it'll come by and want you to put in those 3 answers. Okay, so not too bad. I'll send y'all a video doing this stuff on the calculator later too. All right, y'all, so let's see. This one we're going to find h of negative 9, h of negative 4, h of 5, and h of a positive 9. We're given h of x equals, and y'all, this one has 3 equations. I got negative 2x minus 20 for x less than negative 7. It equals 5 for negative 7 less than or equal to my x less than 5. And then it's going to equal x plus 8 for any x that is greater than or equal to 5. So this middle equation 5, that's a constant equation. So for any x value between negative 7 but still less than 5, our equation is going to equal 5, and that's it, okay? So let's find h of negative 9. So negative 9 is less than negative 7, so I would use the first equation, which is negative 2x minus 20. In place of the x, I'm going to put my negative 9. So negative 2 times negative 9 is 18. 18 minus 20 is going to give me what? A negative 2. So h of negative 9 is negative 2. Next, they wanted h of negative 4. So negative 4 is not less than negative 7. Negative 4 is in between a negative 7 and a positive 5. So just think about your number line, okay? So 0 here, that'd be negative 3, negative 2, negative 1, and then over here, positive, remember. So negative 4 is definitely bigger than that negative 7, but it's less than the 5 over here. So we're going to use the second equation, which says h of negative 4 equals 5. There's no variable to plug in for that, and so we're done. Next we do, what's next? H of 5. So 5 is not in between a negative 7 and it's not less than 5. Here it says it can equal 5. So 5 equals 5 is true. So I'm going to use this equation, which is x plus 8. In place of the x, oh, my pen came apart. In place of the x, I'm going to put the 5. So I get 5 plus 8, which will be 13. And then I think I had one more, was what, h of 9. So I'm going to put it right here. So h of 9, we got to see 9 is not less than negative 7. 9 is not in between negative 7 and 5. 9 is greater than 5. So I used the last equation, which was x plus 8. And replace the x with a 9. So I got 9 plus 8, which will equal 17. All righty, let's see. Trying to decide if I want to do this 5.4 today or tomorrow. I think I'm gonna wait and do 5.4 tomorrow. That way we can review for the test Wednesday. For test 2 Wednesday. So that'll be it for our lectures. So I'm gonna stop my video. Y'all got this copied? All right.